Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve questions from ILS chapter in Radio Navigation, Keith Williams book. In my previous lecture, I solved the first 10 questions. In this video lecture, I am going to solve the next 10 questions. So let's begin. Question number 11. Now, ILS is subject to false glide paths resulting from what? Spurious signals reflected by nearby obstacles, multiple lobes of radiation patterns in the vertical plane, backscattering of antenna, ground returns ahead of the antenna. So remember, this is your localizer signal. So your localizer antenna, which is located on the opposite end of the runway, will transmit uh, localizer signal in the VHF band. In the VHF band, on any frequency which is between 108 megahertz to 10112 megahertz, provided the frequencies have odd decimals. Provided the frequencies have odd decimals. Okay. Now frequency, the signal that is transmitted is amplitude modulated. So the left hand side is amplitude modulated at 90 hertz, and the right hand side of the signal is amplitude modulated at 150 hertz. Similarly, your glide slope transmitter will transmit the signal, glide slope signal, uh, on a frequency which is in the UHF band, starting from 328 megahertz up to 335, around 335 megahertz. Okay, 328 to 335. Now these glide slope signals are also amplitude modulated such that 90 hertz signal is above the 150 hertz signal. Now, if you want to follow the extended center line of the runway, we want to be positioned on the center line of the runway, want to follow the center line of the runway from start to end, you will have to follow this line, okay, which is the extended center line of the runway. This extended center line of the runway signifies that both the signals, both 90 hertz signal and 150 hertz signals are received in equal proportion. So when you are flying exactly the center line of the runway, you will receive both 90 hertz and 150 hertz signals equally. Similarly, when you are flying the standard glide path 3 degree, you are established right on the glide path and you are following that glide path correctly, okay, this 3-degree glide path, your aircraft will receive both 90 hertz signal and 150 hertz signals equally. Okay, next. Now, your glide path transmitter is subject to one disadvantage. It can produce a false glide slope signal, a false signal. Okay, so this is the real signal. It can produce false signals, and this false signals will be produced above the it. They will be produced above the original glide slope signal. So this is the correct glide slope signal, the correct original glide slope signal. So any false glide slope signals that are produced, they will be produced above this. Okay, above this. They won't be produced below this. They will be produced above the standard glide path signal. So what happens? So if this false glide slope signals are produced, your aircraft may follow this glide slope, this false glide slope, instead of following this correct glide slope for landing. Okay, so that is a problem. So you can see over here. Okay, so here this aircraft, now this aircraft is on the correct glide path 3 degree glide path. Okay, 90 hertz signal, 150 hertz signal, and all the false glide path signals are produced or generated above this. So false glide signal like that. So your aircraft, instead of following 3-degree glide path like this, may follow any one of these false glide path signals and fly a steep glide angle. Okay, so that is one thing. So over here you can see this is the correct glide path angle. This is the correct glide path angle that your aircraft is following. But when it continues its journey forward, it comes in contact with false glide slope signal which is above the correct one, and it tries to capture that glide slope signal and follow that glide slope signal. So it will so aircraft's autopilot system will automatically pitch up to capture that false glide path signal. Okay, so they may ask you this question in your ATPL Viva exam or airline Viva exam. How do you come to know whether you're following the correct signal or the false signal? So you can tell them this answer over here. Reversals cause the autopilot to pitch aircraft away from the desired correct 3-degree glide slope. Okay, so all of a sudden you're flying a 3-degree glide slope down to the runway. All of a sudden aircraft starts pitching up. That means that's a clue. That's the idea you get that aircraft is trying to capture the false glide path. Now all these false glide paths are a result of ground reflection. So why do we have false glide path if they ask you in Viva? So because of ground reflections. So the correct answer here is ground returns ahead of the antenna. Okay, next. Aircraft carrying out an ILS approach is receiving more of 90 Hz signal and less 150 Hz signals from both localizer and glide path. So the ILS indication will show what? Okay. So just now I said, if you intend to follow the correct extended center line of the runway, you will be receiving both 90 Hz and 150 Hz signals equally. Okay, if you intend to follow the correct glide slope 3 degree down to the runway, you will again receive both signals 90 Hz and 150 Hz equally. Now, if you are receiving more of 90 Hz signal and less of 150 Hz signal, that means your aircraft is not positioned on the center line of the runway. It is either to the left hand side or right hand side. Now, if aircraft receives more 90 Hz signal, that means aircraft is somewhere here in this band. That's why it is getting or receiving more of 90 Hz signal and less 150 Hz signal. And with respect to glide path, your aircraft is somewhere here. Since it's receiving more of 90 Hz signal, your aircraft is in the 90 Hz band. Is in the 90 Hz band. That's why it's receiving more of 90 and less of 150. Now, this is the actual situation. This is what is happening. Now your ILS indicator, which is nothing just like your CDI indicator for OBS, right? It has this localizer needle and glide slope needle, right? Now, if the work of this CDI indication is to give you the solution, a solution to a problem. So if you go to the left hand side of your desired runway center line, you must be established on the center line. But if you get deviated to the left hand side, this indicator will tell you to go right. So this needle, this vertical needle will go to the right hand side, telling you pilot fly to the right hand side. That is where your runway center line is. Let's say if you instead of following a 3-degree glide slope correctly, you are above the glide slope. So this instrument will tell you, okay, this instrument will tell you to fly down, okay, because that's where your correct glide slope is. You have deviated above it, so come down to capture it. Okay, so this glide slope needle, this needle will move down like this, telling the pilot to fly down, okay, because that's where the glide slope is. Now in this case, you are to the left hand side of the runway center line. That is the problem. So what is the solution? What will the indicator tell you to do? The indicator will ask you to fly right hand side. It will ask you to fly right hand side like this. Similarly for glide slope, you are above the glide slope. So the CDI indicator will tell you or ask you to fly down. It will tell you to fly down like this because that's where the correct glide slope is. It's below you. Okay, so the correct answer will be the localizer needle will tell you to fly right. Okay, and the glide slope needle will tell you to fly down. So option Bravo is the right answer. Next, you are carrying out a 3-degree glide slope approach, and there is a reduction in ground speed from 150 knots to a new speed of 120 knots. So ground speed reduces or decreases by 30 knots. The effect of this change in speed on aircraft's rate of descent will be what? So remember, whenever ground speed decreases. It can be because of either headwind, increase in headwind component, or pilot's action. Pilot reduces the engine power deliberately. Okay, so whenever ground speed decreases, What is the direct consequence of that? The rate of descent of your aircraft increases. That means your aircraft will come down towards the ground at a much faster rate. If before the reduction in ground speed you were descending at 500 feet per minute, now after this reduction in ground speed you will descend at 600 feet per minute, 700 feet per minute, much more than 500. Okay, so your rate of descent increases. So what will happen? See, this is your runway. This is your glide slope. Initially, you are correctly established on the glide slope 3 degrees like this. Okay. Here the speed was 150 knots. Now all of a sudden your speed reduces or decreases to a new speed of 120 knots. So what did I just say? The rate of descent will increase. So when your rate of descent increases, you will come down towards the ground at a much faster rate. So instead of following this glide slope down to the runway, you will find yourself below that glide slope somewhere here. Okay, because your rate of descent has increased. So instead of maintaining a constant rate of descent 500 feet per minute down to the runway, now all of a sudden your rate of descent is 700 feet per minute. So you have found yourself below the glide slope. Okay, so this is the problem. Okay, glide slope is above you, you are below the glide slope. So what happens? Rate of descent increases. So this is what happens. You will be below the glide slope. You will undershoot the runway. Okay. So the solution is whenever this happens, ground speed decreases. Pilot must add engine power. You add engine power, the forward speed of your aircraft increases. So as a result, ground speed of your aircraft will increase. As a result, you will prevent your aircraft you will prevent your aircraft from descending at a very fast rate, at a faster rate of descent. Okay, so you will have to manipulate the engine power continuously to maintain your aircraft on the glide path. Okay, so what will happen? You will have to add engine power. You will have to increase your ground speed. When this happens, your rate of descent will be in control. It will be in control. If you don't adopt the steps immediately, your rate of descent will increase excessively. Okay, so now by what amount will you decrease your rate of descent? You will stop that rate of descent from increasing. So the formula is the change in rate of descent equals to 5 times change in ground speed. So 5 times 30 degrees. Your speed has decreased, so minus 30. So minus 150 feet per minute. That means you will have to decrease or reduce your rate of descent by a factor or by an amount of minus 150 feet per minute. Next. The principle of operation of an ILS localizer transmitter is based on two overlapping lobes that are transmitted on the same frequency and carry different modulation frequencies. So option A. Like I said, localizer antenna which is situated at the other end of the runway will transmit these two signals. It transmits these signals in the VHF band between 108 MHz to 112 MHz. All the frequencies must have odd decimals. Even decimals are reserved for VOR. This frequency, this main carrier frequency between 108 MHz and 112 MHz will be further amplitude modulated 90 Hz and 150 Hz as shown in the picture. Okay, that means it has same carrier frequency, same main frequency, but different modulation frequencies. So correct answer is overlapping lobes that are transmitted on the same frequency VHF band, different modulation frequencies. In which frequency band does ILS glide slope transmit? So ILS glide slope transmit in the UHF band starting from 320 MHz, 328 up to 335 MHz. So option Charlie. Localizer and marker beacons transmit in the VHF band. Apart from that, I want you to remember this designators for every radio navigation equipment. For ADF, it's non-A1A, non-A2A. VHF radio telecommunication is A3E. For high frequency radio telephony is J3E, Juliet 3 Echo. VOR Alpha Niner Whiskey. ILS Alpha 8 Whiskey. Marker beacons Alpha 2 Alpha. DME Papa 0 November. Okay, so you have to remember this designators for every radio nav equipment. Assuming a 5 dot display, what does each dot on either side of the ILS localizer cockpit display represent? So you have this CDI indicator, right? So if it is 5 dot indicator, so center dot is the one. So every dot will be equal to what value? So you have to remember this. For localizer, if it's a 5 dot indicator, if it's a 5 dot indicator, every dot will be equal to zero point 0.5 degree. So 5 dots will be equal to 2.5. So maximum deflection is 2.5 degrees, left or right. So every dot will be equal to zero point 0.5 degree. If it's a 4 dot indicator, every dot will be equal to 0.625 degree. Similarly, you will have to remember the values for glide slope. 5 dot each dot 0.14, 4 dot each dot equals to 0.175. Okay, so correct answer is zero point 0.5 degrees, option alpha. Next, outer marker transmits on 75 megahertz. Like I said, every marker beacon will transmit in the VHF band 75 megahertz, and this frequency will be further amplitude modulated according to different marker beacon. Outer marker 400 hertz, middle marker 1300 hertz modulated, inner marker 3000 hertz modulated. So it has an oral frequency of what? So it has an oral frequency of 400 hertz. It's written here, 400 hertz. Every 10 knot decrease in ground speed will require an approximate change in rate of descent, which is equal to 5 into change in ground speed. So 5 into 10 knot decrease. So 5 into minus 10 minus 50 feet per minute. So you will have to change your rate of descent. You will have to decrease your rate of descent by minus 50 feet per minute. So correct answer is option Bravo. Next, ILS glide paths provide azimuth coverage, means horizontal coverage, dash degree each side of the center line of the runway to a distance of dash miles away from the threshold. So remember this diagram. So it will provide guidance 8 degree either side of the runway, 10 miles away from the runway. So correct answer is option delta. Okay. Next, the rate of descent to maintain a 3.25 degree slope at a speed of 140 knots is what? So rate of descent equals to slope into speed into 101.3 feet per minute divided by 60. So 3.25 into 140 into 101.3 divided by 60. 3.25 into 101.3 into 140 divided by 60 is 768 feet per minute. So the closest option here is option alpha, 800 feet per minute. So this concludes our lecture. I hope you have understood all the 10 questions I have answered in this video lecture. If you have any doubts, comments, feedback, let me know in the comment box of this video lecture. Let me know if you want me to make any specific video that you find on a topic that you find difficult. Let me know in the comment box. In my next video lecture, I will definitely do the next remaining questions from this chapter. So let's meet there.